Welcome back to Tech Tips. Today we're talking about controllers. Most of the controllers you're going to see talked about for escape rooms are these three plus PLC. Now, PLC is an industrial grade type of controller that uses ladder logic to control things. And this, of course, is an Arduino. And there has been so much already written about and videos and all sorts of information out there about PLC and about Arduino that I'm not really going to cover those today because it's been done. I'm going to cover these two controllers. This is the Fright Ideas BooBox FlexMax, and this is Escape Room Tech's Badass controller here. And these are a little different than the other two. These don't require what I would call programming. They require a separate kind of user interface that we're going to go over about that here in a little bit. But first, the main thing I want to show you is how to wire these up. That's the main thing, and I see where a lot of people get stuck on, is how to wire these properly. The first controller we're going to talk about is the Fright Ideas BooBox here. Now, this is a FlexMax. This thing has 16 outputs and 8 inputs and servo control and a bunch of other stuff. And we'll talk more about that later. But there are smaller versions of this called a Flex, and there are versions that don't have as many outputs. You got a 4 and an 8 as well. So Fright Ideas makes a whole bunch of other different types of controllers depending on what you're looking for. But this is the main one. This is the one that can control a whole room almost. Generally what we do with these is we have one in each room to kind of run the logic of the room itself, and then we'll use smaller ones for the individual puzzles like that. It just depends. So generally what you'll see in the instructions is a wire going, because here is your plus, and you'll see here, this is your common. There's a common right here. And C, of course, we discussed this in other videos, C is for common. That means just the common wire that everything shares. Now, in most illustrations, almost everything you're going to see is going to see a wire running from the red line into here, and another one running to here, because each of these blocks, these terminal blocks here, these only have power for these blocks. So like that's why there's a C here and a C here, because the one common here can't power all 8. You need this power is this for, this power is this for. So you'll have a jumper going from here to here. All right. And now next to the positive, of course, you have your negative, and this runs out to whatever your button is. Let's say this is a button like this. And then this here would be running it to your number 1, like that. That's the very basics of it, because what's happening here, these inputs are triggered with voltage. All right, they trigger from about 9 to 24 volts, depending on how much power you're running through this box. These can handle 12 to 24, but I have found that 9 volts can get these to trigger, but if you're running very long leads, it probably is going to have so much voltage drop, it's not going to work. So 12 volts is about what you want to stay with here to trigger this. So you can actually not use this setup at all. This setup can actually be ignored if for some reason you were wanting to attach a battery to the button, right? So I'll kind of show you what I'm talking about here. So if you were to run a line from here, and then this is your button, and then this ran to let's say a 9-volt battery, just for fun, and there's your negative, and then over here is your positive, and then that ran into your common, this would still trigger. You wouldn't need all this extra wiring stuff here. So what's happening is the box, you're using the native voltage of the box to trigger the inputs. All right, that's just the way it works. So you need voltage to make these inputs trip, essentially. And that's how the other controller is as well. So those are your two options, but it is very rare that you will ever need to do this. I've never had to do this with one of these controller boxes, but that's not saying you won't have to. So now we're going to look at this in a practical sense, all right, a practical application. I've already wired my jumpers in. Now, if you're not using these inputs, there's no reason to have this wire here. You can just forego that one. But as you see, I have these kind of daisy chained off each other. You can run 2 wires. You can run one from the positive. You can run both from the positive. You can have one here and then have this one jump over here. This is just a shorter wire to get in the way, all right? So your most basic setup is going to be something like this, some sort of wire or sensor or something like that. This could be a reed switch. This could be a toggle switch. This could be any number of switches. This is just a momentary push button, okay? So I'm going to put one end here into the negative, like this, tighten that down, and then I'm going to put this in input 1, assuming that is what we need to do. Now what's nice about this is what I like about these boxes is you don't need to have anything wired up to test the inputs. You don't have to have a show in, you don't have to have anything programmed. There's a way to test it, and I'll show you how that works here. We're going to plug this in. This is my 12-volt power supply, and that goes here. By the way, speaking of power, these plus and minus, these positive and grounds and negatives here, these can actually supply power out just in general, right? So, and we'll talk more about that later with some other types of sensors. So now if you watch, when I push this button, you'll see an orange LED light up right there. See that? That means that this is making connection, that it's working. And this is a great way to troubleshoot these when something is going wrong. You go and let's say you have this in a closet somewhere, you have somebody trip something, and if you don't see an LED going on, that means there is a failure between your points, right? Your button's not working, a wire has come loose, something has happened. So because this will always light up like this, and it's the same for the outputs. When the outputs trigger from the controller, they also light up. So they have this kind of feedback that lets you know what's going on. So now, if you're going to attach multiple inputs, there's a easy way to do that as well, and I'll show that to you now. So now, instead of trying to cram a whole bunch of wires into your negative here, because if you have all of these inputs filled, you have to have them all running to this negative port. Well, that gets a little cumbersome after trying to wire 8 wires and stuff them into this port here. So the easier thing to do is to use a jumper wire like this. So I'm going to throw this jumper wire inside of here like this, and we're going to use Wagos, these little guys here, also known as lever nuts, which was my nickname in college. So these allow you to jump a whole bunch of things at once. And obviously these are not the only option. There's also like the little bus bars and things like that. But for this demonstration, we're going to be using a Wago. So what's going to happen is I'm going to throw this here into the first port and lock it down. And then we're going to take this button, throw it into here, lock it down, and we're going to use this as an example of running to like another sensor or something else, like from a long lead or something like that, just having this port here. And again, this runs into here. So now I've got these connectors, multiple connectors running, and from here on out it's the same thing. You're going to now just wire this up into port 1 like this, connector 1, or input 1, and then now this one goes in input 2. And this helps tidy up your wires and make things a lot less confusing here. Just being able to have a place where all of these wires are going to run into one spot will help you immensely, especially when you're trying to troubleshoot later. So I would suggest picking up some of these, or like I said, some bus bars that basically essentially do the same thing as this, that distribute all the voltage down across a rail like that. And you can find information about that online, and I'll throw some pictures of them so you know what I'm talking about up here right now. Okay. Now similarly, you'll have to do the same thing here with the outputs, because when you have the outputs here, this is the same thing as I was talking about earlier with this common only works for these 4 blocks here. Well, the same thing, it happens up here on these output blocks. So this plus symbol here is just a positive that you have going on here like this. You have a positive, and that only works for these 4 outputs right here. These don't work for here at all. So each one of these outputs has a positive whatever, block. Anyway, input. So what's going to happen is you're going to want to run, if you have 4 outputs on this one block, you're going to want to use one of these here to run everything to just clean it up. Same kind of concept like that. So this would be your positive running into here, and this would be your positive rail across this. And then you'd have your other item, let's say we're using a light like this. You would run one end into here, which would be your ground, your negative end, like this. And then, of course, your other and would go into your rail or your lever nut or whatever like that. And then you would have a positive wire running into this here. It's pretty much the exact same as what was going on with the inputs, because these blocks are powered, again, by the controller. So if you put 12 volts in, you're going to get 12 volts out. And if you put 24 in, you get 24 out, like that. So, and these do have limitations of how much amperage they can deal with. So make sure you read the instructions, and because they will tell you how much each one of these blocks can handle and how much collectively they can handle. And there is protection circuitry inside of these, so if for some reason you overload something, it will basically kind of shut off and reset and keep doing that. So it can't, there is ways to short it out and destroy it. But for the most part, you have to really screw that up to destroy one of these. So just be aware. So up until now, I've showed you basic 2-wire inputs, right? Very basic buttons and switches and things like that, which is what you're going to mostly encounter. But sometimes you're going to encounter these things with 3 wires, like this. And when you encounter something that has 3 wires, 3 leads, generally what that means is you need to give it power, and then it has a 3rd wire or more for a signal, similar to how a relay has a positive, negative, and an in or a signal, right? So what I have here are 2 different types of proximity sensors. This is a capacitive touch sensor, which means it reacts to touch, organic materials, non-metallic things. And this one is an inductive, which responds to metallic things, but not touch or skin or anything like that. So what's going to happen with these? Now, this is one of those situations I talked about in a previous video where you'll encounter wiring that is not what you're used to, right? So these are brown, blue, and black. Now, generally, on the side of these, they'll tell you what they are, but sometimes you encounter ones that are written in Chinese, but thankfully this one is both. So this tells me that the blue is negative, the brown is positive, and the black is your signal, basically. Now, the way you hook these up depends upon what type they are, and the types you use with which controller also depends. This guy right here, and thankfully they almost always say it on the side, this is an NPN, normally open, and this is a PNP, normally open, okay? So be aware that certain ones of these will only play nice with certain ones of these, and also depends on how you wire it up. Now, this one can kind of take both NPN or PNP, but you have to change your wiring setup. You'll have to run your common to the negative, to the ground here, and there are times when you're going to need to do that for some reason. It'll be easier for you to have one of these blocks have a common negative, right? Depending on the sensors and the things you're using. So be aware of that you don't have to use the positive for this. It is not necessary. But in this situation, to get the most out of this, we're going to be just kind of talking about the NPN here, to leave it in this situation, like that. If you're using a PNP, you have to swap these, but we're not going to talk about that right now, and we'll get back to this guy later. So you're going to run your negative to the negative port, obviously. You're going to run your positive to the positive port right here. And now that's going to be sharing with this wire. These wires will be sharing the same port, the jumper and this. And now you're going to run your signal wire to your input there, number 1. Okay, so that's basically what's happening in this situation. Now, as I said, if you're using the opposite of this, a PNP instead of an NPN, I'm going to write that down for you guys there. NPN, like that, just so you have it in front of you. You're going to have to, like I said, to swap the jumpers to the negative rail. But again, we're not dealing with that right now. So yeah. So I'm going to show you the practical setup for this. Here you'll see I've actually taken one of the jumpers out just because there's no reason to have one over here for what we're doing. So again, we're going to take and place the blue, because it's the negative, into our ground, like that. And the positive is actually going to share the positive here. This has to get kind of shoved in there with that guy. There's no reason to use a Wago for something like this when you're just putting like 2 wires together, like that. And finally, the black goes over here to input 1, like that. And then we plug it in, like this. There we go. And you'll see when I touch this, the little LED should light up. There we go. You can see that is lighting up right there. And you can also see the LED on this is lighting up. So that's the other thing you can do with these types of sensors is you can make sure they're getting power. You don't even need this wire here. If I was to disconnect the signal wire here from this would still light up. So that way this is how you know it's kind of getting power like that. So, and again, this is an NPN sensor. To set this up, if you were to need everything with this positive rail, these are the kind you're going to need. Now we're going to put it all together. I have my input wired up. I'm just going to keep this guy here. We have a 12 volt LED little thing wired up to there. And right here we have the SD card, which is what controls the show logic here. Now, you can actually upload the show directly into the controller and don't need an SD card, but I find it's best to do both. I like to upload the show and then put the SD card in case the SD card messes up and you have to remove it. You can still run your show from the box and everything like that. Of course, any changes you have to make have to go on there. Now, to program this, you use a free program that Fright Ideas has called Director. And it is a kind of a visual interface. And if you're like me and you're a performer type and you think of the way this thing works by scenes as a show, it's really easy to navigate. Now, I know some people have trouble with that, and I'm going to make some more supplemental videos that go into more detail about that down the line. So look for that. So now we're going to take the SD card and we're going to put it in like this and you'll see the LEDs kind of flicker here. There we go, and it's ready to go. And what's going to happen is I'm going to touch the sensor, and the LED is going to light up. Ta-da! Magic! And then this stays on for however many seconds I told you. It's actually also playing an audio file that you can't hear because I don't have a speaker hooked up. That is one thing that the FlexMax and some of the other controllers have, which is nice, is audio. And some of them don't. But you can look into all that yourself. So now that it's back to here, I can tell it to do it again. Just like that. So that is the basics of wiring a FlexMax. Here's something interesting about the Fright Ideas controllers. Now, you'll notice how earlier I said there's different flavors. You have 4 outputs, 8 outputs, and 16 outputs, right? But what's interesting is if you buy one like a 4 and 8, and it turns out you need more outputs, you can actually upgrade it. You don't have to buy a whole new controller. You're not screwed. You can actually buy a firmware update from the website, and it's all automated. You get it quickly, and the only thing you'll need is some of these Phoenix headers here. So if you happen to have some of these laying around off of another controller, or my advice is just get some of these anyway. You can get these off the Fright Ideas website. They have them under accessories. Just get some of these as extras just in case you ever need them, or in case you need to upgrade your controller, because then all you would have to do is be like, hey, this controller's an 8. It turns out I thought I needed an 8. Now I need a 16. You upgrade the firmware. You can now do 16 outputs, and then you just pop these guys on, and voila, you do that. And you only have to just pay the difference, right? So if you bought an 8, you only have to pay the difference up to the 16, which is interesting. So I just thought that'd be something that you should know in case you ever get stuck in that situation. Now we're going to talk about the badass controller here, this guy. This one is unique in that it actually has this Ethernet port that lets you monitor the inputs and outputs and override them from a customized proprietary interface, right? But these work a little bit different than the other ones, and what's interesting about them is they can work as a room controller, similar to the FlexMax. However, you can also use it for games. You can basically run one particular game off of it that it is specialized for, RFID, knobs, things like that. And what's interesting is it also has 2 relays, like normal clicky relays on it. I've heard that they're going to move over to solid state at some point, but this is what you get currently at the time of this video. As you can see here, you have 8 inputs, and you have 6 outputs right here. And with these relays, that gives you obviously 8 outputs and things like that. But let's go over some of the nuances and the wiring of this as well. Now, similarly to the other controller, these inputs are powered off of voltage. And again, you can power them from the actual board itself using the voltage. However, and again, this takes 12 to 24 volts. Just so you know. However, there's no common here, right? So you're actually going to end up doing something very similar with the Wagos and things like that, except you just won't be having to use any jumper wires or things of that nature. So you would have your positive running. And if you have multiple inputs, again, this is where you'll run it to your Wago here. So you have all of your wires then running out of here. So let's say here's your button like this, and that will go into your input 1 right here, not the negative. The negative doesn't do anything. You run this into your bus, or if you're just using one button, which how often do we get to be that lucky, it would obviously just be running into here like that. But usually you're going to be having multiple inputs coming across like this. So you're going to also have a lot of settings. This inside the proprietary software, and I'll go over a little more of that here in a little bit. But again, I'm going to show you how to do this practically. Now you'll notice I've actually already wired up my LED to this box, and the reason for that is you don't really get a visual feedback on this like the other one. You don't have little LEDs that tell you if these are working and everything like that. So there is you can get an audio cue because you can have the relays turning on and off. So when you go into the Badass Manager to program this with the interface, one of the things you can do is you basically have to use it. You have to use the Ethernet. You don't have an SD card or anything like that, but you hook it to an Ethernet. Now, Ethernet is not internet. All you need is basically a router to be able to network this together, right? You would basically need a router, a computer, and this. So you don't have to. You can do this without internet, just so you know. And so you hook this up to that, you program it, and you can unplug this, and it'll retain all that information. So you don't have to have this constantly hooked up to your system. But if you want to monitor the inputs and outputs and the relays, you will need it hooked up to some sort of router and computer, just so you know. So right now I've got this hooked up, and you can hear the relay click because I've got it programmed to click, and then this, and it turns off and comes back on. That's just kind of my little test show to show you guys what's going on here. So if you just program a relay to turn on, or you have a relay, you can hear that and go, okay, well, the button is working. Now, because there isn't a common on this, you have basically, you always are going to be running from the positive. You're always going to have a wire running from the positive, and then wires going into your inputs here like that. So the negative is just if you want to run power out of things, basically, because you can power other stuff off of this as well. So let's see, on the outputs, it's very similar. You're going to want to run from the positive rail and then run your stuff into here, very similar to the other controller I showed you. So everything would start here and then go off of this. Now, the relays are very interesting, and this is something I want to show you that is nice. So normally with a relay, you would have to have, and this goes back to our episode on relays. Everything is the same. Here, it is wired up. You have your NO, your common, your normally closed, right? So normally you would have your item, that you would want to have light up, or whatever, right? And so you'd run it to your power of some sort. So let's say you have an exterior source. Here's your power, right? Here's your positive, here's your negative. This would be running into this. This would be running into your common. This would be running into your normally open or normally closed, whatever it is, right? But the nice thing is with this, you don't have to do that because there are power ports here on the ends, right? There's positive and there's negative right there, okay? So what that means is I can actually run relays. Now, obviously relays like this are also meant to run like higher voltage stuff. With the FlexMax, you cannot and you should not run anything over certain amperages, and definitely not more voltage than it can handle. Like the outputs on the FlexMax cannot handle 110. But these relays inside of here can handle 110 and much higher voltage, right? And they're also 10 amp relays, like most relays, which means they can handle a lot of amperage. These can control and drive like linear actuators and higher amperage to things like that. But if you don't need that and you're just running 12 volt things, like we'll say this thing here, then you can actually run it from this, and I'll show you what I'm talking about. So I'm going to put the negative here into the negative like this, and let me tighten that down. And because I've got the relay 0, that is one thing also I want to mention here. You'll notice is the relays and the outputs and the inputs all start with 0, not 1. That is just a preference of theirs. So 0 is 1, and then 1 is 2, 2 is 3. You'll get the hang of it, trust me, it's not that hard. So let's put this in. I'm going to put this in normally closed on relay 0. And the reason for that is because right now the relay is actually on currently. So right now, this would be like if you had a maglock installed onto this thing here. And of course, now we need a jumper wire. So I have a jumper wire here to run to the positive rail. And again, this is just like wiring up a regular relay, which we've already gone over. And then this is going to go into the common right here in the center, completing the circuit, if I remember how to undo these. There we go. And like that. Now, if I push the button, the relay turns on, makes the connection, lights this up, and it's all being powered off the controller itself. And that is really handy in a situation like this. So, because most of the time you need external power for relays, but thankfully they've thought of that. So, these are your basic wiring setups for this. This one is a little easier to follow and understand than the FlexMax. So just keep that in mind when you're trying to map out what you need. So now we're going to talk about using 3-wire sensors, similar to earlier. And with this controller, because it is a high trigger, you need to use a PNP sensor. NPN will not work on the FlexMax. You can swap out the common, but because it's not a common here, you have to use a PNP, just so you know. And so if you get an NPN, because a lot of places will tell you that's what you want to use, that's not always the answer. So as you can see, I've already got it wired up here. You've got your positive and negative. This means it's getting power. And you can see here the LED comes on. Of course, it's not doing anything because I don't have the signal line hooked up into it here like that. So I'm going to place that into input 0 like that. And now when I trigger it, the relay will go on and turn the light on just like that. So there really isn't any difference in the wiring setup. You just have to remember that you need a PNP sensor. And again, everything is powered off of the board itself, and it's just that easy. So I'm going to show you the back-end visual interface of how to program this and kind of what's going on here. Now, of course, to do that, we have to plug it in here. And the Badass Manager is a visual interface, but it is a different visual interface than the Fright Ideas Director. It's more text field and drop-down menu based, but it is still easy to understand. And there's already a really good video on the Escape Room Tech's website that kind of walks you through the basics to help you understand it. So I'm not going to do too much of that here, but I did want you to see it and see what's going on, right? So now if we look at the game tab here, you can see that there's a whole bunch of red lights, but there's one green light, and that means that it is saying that this relay is on, because it is. I've told it to be on. It is on right now. And what will happen is when I hit this button here, the input 0 will light up, and then output 5 will light up, even though I've got not anything attached to it currently. That will light up, and then they'll go off. So you'll see that happen as I do this. And then it goes off like that. So you can monitor and see what's going on. You can tell if something's wrong. And the nice thing is, if for some reason you see that people have placed items correctly and one of them is just not triggering, let's say you have a bad read switch, something has happened, then you can override it. You can say, hey, boop, you hit the button, pops your lock, plays your sound effect, plays your scene, whatever, and you're good to go. And there is a version of this that does come with audio, has an audio interface. You can run audio from this as well. And there's a bunch of options for this thing here, and I'll make a more in-depth video based on some of that stuff later. But as of right now, this is, as I said before, this is the basics. I just want you to be familiar with kind of what's going on, or if you're trying to make a decision of what you want to use, hopefully this will help inform you. So you're saying to yourself, which one of these is best for me? And that really depends on the application. But if you're like me and you want to use this for certain things, because this can control like servos and other things like that, and this has some different options, why not use both, right? You can wire the output from this to a relay and wire it up to the input of this, which then lets you monitor the inputs and outputs. So your outputs would be your inputs here, and then this would be running out to your maglocks and the things you're supposed to have happen and things like that. So you can use both in conjunction with one another. You'll see here when I'm going to hit this, turns the relay on, turns on this light over here. So now you can have one or the other talking to each other, so everybody kind of knows what's going on and everything like that. Obviously, it's not necessary because this can also act as a room controller similar to this, but because they both have different options that the other one doesn't, it's maybe best to just use them together if that works for you, right? They do play nicely together. It's not like an Apple product and a PC product. Sorry, that was a low blow. Now there is, of course, the much simpler option where you don't have to get the relay involved, where you have the Badass controller first and the Flex Max or other controller here. I'm just showing you the more complicated way of doing it if you needed one to be doing something else. And so in this situation, the inputs are going into the controller here and the outputs are coming out on this side. So you'd have to figure out how you would do your monitoring and your overrides and everything like that. But it works just the same as you can see right here. Same kind of concept. Input here, output here, here. But you don't need the relay because this is making the connection here. So you'll see there's no jumper wire on this involved because you don't need the voltage coming in from the positive port here, and all you need is the voltage to trigger this here, as I mentioned at the very beginning of the video. One little last bit of information I thought I should give you is about these terminal blocks they have here. The common name for them that I know them as is Phoenix terminal blocks, right? And let's say you've got these boxes wired into some strange prop or closet, and it's hard for you to, you're trying to get in there, and it's very awkward for you to get to the places here. Well, what's cool about these is they come out. They just unplug, just like that. You put your thing in, you can wire it up, and then just plug it back in, and you're good to go. It's very handy, and a lot of people I don't think know about this. These just pop right off the boards right here. These are actually easier to disconnect than these guys. These require kind of either a good angle, or I just use a flathead screwdriver, kind of pop it up. Just be careful. Obviously, you don't want to bend the pins here. Be careful of that, but same kind of thing. You sit here, you put your terminals, so you put your stuff in, and boom, they're good to go. Thanks for watching this much longer than we intended video, but if you have any questions, let us know, and I hope this will help you make a decision on the controllers that you need, either one or the other, or both. Hey guys, make sure you check out some of these other videos we have here, and of course, if you want to keep up with anything we're doing, make sure you subscribe, click the bell, and make sure you also check out testsubjects.com for more info, and if you have something very specific you want us to go over, please let us know in the comments below. See you next time.